Assalamu alaikum, brothers and sisters. Welcome to the Journey of Quest, where we quench your thirst of knowledge. Have you ever wondered how scientists uncover the secrets of Earth's ancient climate? Enter the world of ice cores, the silent storytellers of our environment. These elongated cylinders of ice drilled from the vast ice sheets of Antarctica and Greenland serve as meticulous archives. Each layer of ice encapsulates a year, or even a season, preserving tiny air bubbles and substances that narrate the tale of our planet's atmospheric conditions over millennia. These frozen time capsules deep within Earth's ice sheets hold the key to unlocking our planet's climatic past. Let's take a moment to understand how ice cores are formed. As the snow falls in the polar regions like Antarctica and Greenland, it begins a centuries-long process of transformation. Initially light and fluffy, the snow gradually accumulates layer upon layer. Over time, the weight of new snowfall compresses the older layers beneath, turning them into firn, an intermediate state between snow and ice. As more snow piles on and the firn densifies, it eventually metamorphoses into solid ice. During this process, the air bubbles that were once trapped between the snowflakes are also encapsulated within the ice. These bubbles are tiny vaults, preserving a snapshot of the atmosphere's composition at the time the snow fell. Thus, each layer of ice, from surface to bedrock, serves as a chronological record, storing information about Earth's climate history. This process of formation is what makes ice cores such valuable tools for climate study. Through them, scientists can literally peer back through time, uncovering details about temperature, atmospheric composition, and even past volcanic activity. Now let's delve deeper into the drilling process. Drilling ice cores is a scientific endeavor that combines engineering prowess with extreme logistical planning. The drills used for this purpose are no ordinary tools. They are specially designed to penetrate deep into the ice, reaching depths of up to 3 kilometers beneath the surface. As the drill cuts through the ice, it extracts a cylinder that is carefully handled and preserved. This cylinder, which is then meticulously transported to research facilities, holds the secrets of Earth's climatic past. The drilling process itself is an exercise in precision and care. Technicians and scientists work in harsh, freezing conditions, operating the machinery that must function flawlessly in extreme environments. Any mistake in handling can compromise the ice core, potentially distorting the valuable climatic information it contains. The drilling process, though complex, is crucial in obtaining these frozen time capsules. Through this intricate dance of technology and human determination, we are able to unlock the icy archives of our planet's atmosphere. Once the ice cores are extracted, the real work begins. These cylindrical treasures, retrieved from the depths of the Earth's coldest regions, carry within them air bubbles trapped for millennia. Scientists meticulously analyze these bubbles to measure concentrations of greenhouse gases, such as carbon dioxide and methane. This analysis is crucial as it helps us understand how the atmosphere has changed over time and what it might mean for our future. In addition to gases, the ice cores contain traces of volcanic ash and various isotopes, which are invaluable in painting a detailed picture of past climate conditions. By identifying the specific isotopes and the presence of volcanic materials, researchers can pinpoint historical volcanic eruptions and assess their impact on the climate. This data, layered year by year, forms a unique chronological record, offering insights into how natural events and human activities have influenced the planet. The data extracted from these analyses provide not just a snapshot but a detailed record of Earth's climatic history, revealing patterns of climate change and helping scientists forecast future environmental conditions. The analysis of ice cores is a meticulous process that unveils the secrets of our planet's past, informing our understanding of the present and shaping our response to the future. So, why are ice cores so important in climate change research? As we delve into the icy archives of our planet, we uncover more than just frozen water. Ice cores provide a historical record of the Earth's climate, allowing scientists to understand past patterns and trends. This is crucial because it gives context to the current changes we are observing in our climate. By studying the gases and particles trapped in these cores, researchers can identify periods of significant warming, cooling, and atmospheric changes over hundreds of thousands of years. Additionally, these frozen records help us understand the impact of human activity on climate change. By comparing the data from periods before industrialization to the present day, scientists can directly observe the increase in greenhouse gases like carbon dioxide and methane. This comparison is vital in proving the significant role human activities play in altering the global climate. The data from ice cores not only enhance our understanding but also inform climate policy decisions. They provide solid, undeniable evidence of how the climate has reacted to various forcings in the past, which can be used to predict future conditions and guide global efforts in reducing carbon emissions. This scientific evidence is fundamental in crafting policies that aim to mitigate the adverse effects of climate change. In summary, ice cores are invaluable tools in our fight against climate change. They are the key to unlocking past secrets of the Earth's climate system, helping us navigate the challenging path towards a sustainable future. Imagine drilling deep into the heart of an ice sheet and pulling out a cylinder of ice. That's an ice core. Now, how do we extract these frozen time capsules? It requires a meticulous process involving drilling into the depths of polar ice sheets or glaciers, often in some of the coldest, most remote parts of the world. Take Antarctica and Greenland, for example. These locations are hotspots for ice core extraction because their ice sheets have been accumulating snowfall for hundreds of thousands of years. Scientists use specially designed drills to bore into the ice, extracting long cylinders that provide a frozen snapshot of our planet's past. As the drill descends, it cuts through layers of compacted snowfall from countless seasons, each one leaving a unique imprint. These layers are like the pages of a book, each one filled with information about the Earth's climate at the time it was deposited. Each ice core acts like a diary, meticulously recorded by nature year after year. So how do scientists read these icy diaries? Imagine each layer of ice as a page in a book, each one representing a different chapter of Earth's climatic history. The deeper the ice, the older the story. These layers capture everything from annual snowfall to atmospheric conditions, stacking up year after year, compressing into a timeline of frozen archives. Now, within these layers, tiny air bubbles are trapped, time capsules of the atmosphere from ages past. By extracting these bubbles, scientists can measure the concentrations of greenhouse gases like carbon dioxide and methane. It's akin to checking the Earth's ancient breath for clues. These gas levels tell us how much of these gases were in the atmosphere at different points in time, helping paint a picture of historical climate conditions. But the plot thickens. Beyond gases, ice cores contain other substances like volcanic ash. These ash layers act as bookmarks, precisely dating the ice to specific volcanic events known from other records. Moreover, the presence of certain isotopes in the ice, like oxygen-18, serves as a thermometer. Changes in the ratio of these isotopes from layer to layer indicate shifts in past temperatures, giving clues about heating and cooling trends over millennia. Through these methods, ice cores reveal not just the climate's past, but also its response to various global events. Now let's connect the dots between ice cores and modern climate change. Ice cores, those frozen archives pulled from the icy cloaks of Greenland, Antarctica, and high mountain glaciers, are more than just compacted snow. They are the keepers of our planet's past atmosphere. As we've seen, each layer of ice traps tiny bubbles of air, preserving a sample of the atmosphere, as it was when that layer froze. These samples act as a baseline to understand historical climate patterns and trends. By analyzing the gases and isotopic content within these air bubbles, scientists can reconstruct past temperatures and atmospheric compositions over hundreds of thousands of years. What emerges from these icy scrolls is a narrative of Earth's climate history marked by gradual shifts and sudden changes. The significance of these findings lies not just in their historical context but in their relevance to today's world. The data extracted from ice cores shows clear evidence of the natural cycles of Earth's climate, such as the ice ages and interglacial periods. However, it also starkly highlights the anomalies of recent decades. The levels of carbon dioxide and methane, two potent greenhouse gases, are now substantially higher than at any point in at least the last 800,000 years. This escalation in greenhouse gas concentrations correlates strongly with the industrial activities of humans. By comparing the ancient atmospheres encased in ice with our current atmosphere, scientists have been able to demonstrate that the rapid increase in global temperatures since the Industrial Revolution is not a natural fluctuation but a direct result of human activity. Understanding these patterns is vital for predicting future climate conditions. Models that predict future climate scenarios rely heavily on this historical data. Knowing how the climate responded to similar levels of greenhouse gases in the past helps scientists forecast how it might react to current levels. This deep time perspective is crucial for comprehending the speed and scale of today's climate changes. Extracting and studying ice cores is no simple feat. The pursuit to unlock the secrets held within ancient ice involves braving some of the planet's most extreme and unforgiving environments. Scientists often find themselves working in sub-zero temperatures, battling fierce winds, and navigating through remote, ice-laden landscapes. The logistics alone, from transporting heavy drilling equipment to maintaining a stable, cold chain for the ice cores, present a formidable challenge. Technologically, the field has had to evolve rapidly to ensure the integrity and accuracy of the data extracted. Traditional drilling methods, though effective, often risked contaminating the ice samples with modern air or drilling fluids. However, recent innovations have introduced cleaner drilling techniques that use recirculated fluid or air to minimize contamination. These advancements have significantly improved the purity and reliability of the samples. Moreover, the introduction of rapid on-site analysis technologies allows scientists to conduct preliminary assessments directly in the field, reducing the risks associated with transporting delicate ice cores over long distances. This shift not only speeds up the research process, but also enhances the precision of the data collected. One of the most exciting technological leaps in ice core analysis is the development of ultra-sensitive laser tools that can analyze isotopes in the ice, providing more detailed insights into past temperatures and atmospheric compositions than ever before. Every challenge overcome enhances our understanding of Earth's climatic history. These innovations not only refine our current methodologies but also pave the way for future discoveries that could be crucial in our ongoing battle against climate change. You might be thinking, why does this matter to me? Well, let's connect the dots. The study of ice cores isn't just about unlocking the secrets of the past, it's about understanding our present and shaping our future. The climate patterns revealed by ice cores have far-reaching impacts on society. Take agriculture, for instance. Farmers rely on predictable weather patterns to grow our food, but as the climate changes, so does the predictability. By studying ice cores, we can better anticipate these shifts, allowing farmers to adapt their strategies and ensure our food supply remains secure. Then there's disaster preparedness. Ice cores give us a record of past weather extremes. This data helps us understand the frequency and intensity of events like hurricanes and droughts, enabling us to prepare and protect our communities more effectively. And it's not just about responding to the challenges of climate change. It's about active policy making. By providing concrete evidence of how our climate has changed over time, ice core analysis can inform decisions about greenhouse gas emissions and renewable energy strategies. In essence, ice cores are like a time machine, guiding us through the past to make informed decisions for our future. They remind us that our actions today have long-term effects on our planet. By peering into the past, ice core analysis helps us navigate the future more wisely. In conclusion, ice cores are not just chunks of ice. They are unique time capsules, holding within them the secrets of our planet's climatic past. Through their analysis, we've been able to decode the complexities of climate change, gaining insights into the cyclic patterns of our Earth's temperature and atmospheric composition over thousands of years. This knowledge is invaluable. It allows us to understand the intricate interplay of natural and anthropogenic factors influencing our climate, helping us predict future changes with greater accuracy. In a world where climate change is not a distant threat but a present reality, this information can shape policies, influence sustainable practices, and even alter the course of our individual actions. On a global scale, it can guide us in making informed decisions about our collective future. On a local scale, it can help communities adapt to changing weather patterns and mitigate the impacts of climate change. As silent storytellers, ice cores challenge us to listen and learn, lest history repeats itself with a climate we no longer recognize.